I think the other thing that babies learn is the notion of cause and effect,
Yeah.
which they learn by intervening in the world and seeing what happens. And we have not yet done that at all with LLMs. I mean, they are entirely predictive engines. They're just doing associations. Getting to causality, which is so critical when one interacts with, when one tries to cross the chasm between bits and atoms, that's a huge capability that's missing in current day models. It's missing in models that are embodied. It's missing in the ability of our computers to do common sense reasoning. It's missing when we try to go to other applications, whether it's manufacturing or biology or anything that interacts with the physical world.
The way these models are deployed today, we do all of this offline training, and offline means we deploy them, we put them into a product. It's static. Yeah. It doesn't learn, it's fixed from there. Nothing you do changes that model, its weights. And so that needs to change in order for these things to continuously learn. And the other big hurdle is we humans, we learn through debate like this, right? We discover new ideas, we explore the space of truth and what's possible, knowledge. Models, they need to be able to do that amongst themselves as well. So this idea of self-play and self-improvement. Right now, a major bottleneck, I'm sure Kai-Fu feels it as well, I'm sure we all feel it, is getting access to data that is smarter than our model as it is.